Hey Tech Builders, welcome to Tech Talks with Paul. Have you ever used event listeners to handle off-chain activity for a contract function? Have you ever had any problems with that? Well, I definitely have, and what we're going to talk about today is a way to handle off-chain activity to handle randomization or other functionality instead of using an event listener. I've found in the past that event listeners can be flaky, and sometimes you miss events. And in those cases, if you're 100% relying on events, you end up with problems because you have missed events, and so things don't actually get taken care of like you expect them to. So we're going to talk today about what is an event listener, why we use it, and then we're going to talk about an alternative, and I'm going to show you some code work about it. So let's get started. So here's the Grug website. This is the project that we're working on. It's a degen project, but these guys are great and good, trustworthy team too. So anyway, so this is Grug. So you can go here and you can claim tokens. You can buy the NFTs on Magic Eden. There's a phishing game, which is what we're going to work on, tokenomics, etc. But you can see it's a fun site, grugnorug.wtf. So anyways, so what we're working on is phishing. So we have phishing that are set up. And so in this situation, what you do is you go fishing, and then it randomly catches a fish. So the way it works is it goes fishing and it sends off submits a transaction, but we don't want to actually give the user the random NFT. But when this happens, so we have a back-end processor. So here you can see we're fishing, and you can see it's actually sitting here and it's fishing, and it'll run for a few seconds until the transaction goes through. Then on the back end, it'll submit another transaction, and eventually you catch a fish. So it takes a little while in the animation. We'll keep going until we catch a fish. You can see, look, we caught a silverfish worth 95,000 rug tokens. And so we could fish again, we could throw fish back, keep fish, stake fish. So we're just going to keep fish now. We're not going to fish again. But you can see this is how phishing works. So submit transaction on the front end, and then we wait for a back end process to actually catch the fish. And so we're going to talk a little bit about how this is handled with an event listener and how we're going to replace it with an actual process. All right, let's talk about the processes. So this is the front end. So Grug goes fishing, submits a transaction, which goes to the smart contract, and it emits, when the transaction goes through, it emits an event called go fish and has the user address. So this is the process of the actual fishing. This is all in the front end. Now there's the back end. In the back end, we have a process that's listening for that event, that go fish event. And when it hears it, it submits a transaction to the smart contract and says, hey, catch a fish for Grug. And Grug gets the fish. And so you saw that we caught that silver fish worth 95K. And so this is the actual back end process. So why use an event listener? So what's the purpose? We have our front end, we have our back end. So why can't we just give a fish when the user calls the phishing event? Because on-chain randomization is deterministic, and so users can manipulate it to only catch expensive fish. The way they do that is you could set up a contract that would do the fishing, but would revert if you didn't catch a good expensive fish. And so all you would be doing is spending gas every time. And if you're on chain like Base, which this is on, very, very inexpensive. So you could basically just keep calling that transaction. If it fails, fine, it doesn't matter. But it's going to eventually start going through enough times that would offset the cost. So somebody would gamify it to the point where they would just catch the expensive fish. So we don't want to actually do it in the initial transaction. We need to do it on the back end. There's other services out there like Chainlink, some other RNG services. I choose not to use those. Those continue to, those cost when you're using them. I've also found them to be relatively flaky at times. So I prefer to build something that will last and something that's stable, and less reliance on third-party services as much as possible. All right, so where's the problem? So we have our front end, we have our back end. Where's the actual problem? The problem is sometimes the event listener doesn't hear the event. And so what happens is you don't catch the fish. So the user goes ahead and fishes. The event doesn't get picked up for whatever reason. And it could be an RPC issue, could be any number of problems. So it doesn't get picked up, and so the user doesn't catch a fish, and he just sits there and watches the animation go and go and go. And so now we have a poor user experience, which is what we want to avoid. So what's the solution? The solution is we get rid of the event. Now we can keep the event, but we're no longer going to rely on it. So we're going to take it out of here because it's nice to have, but we don't actually need it. And on the back end, we're going to get rid of all of that. And so the front end, we're going to start logging every time a user goes to fish. We're going to log that attempt in the smart contract itself. So we're going to have an array in that, and we're just going to keep adding phishing attempts to it. Now the back end, we're going to have a special process that is specifically designed just for processing the pending phishing attempts. So what it's going to do is it's going to query the contract on a scheduled basis and say, hey, are there any pending phishing attempts? And if there are, it's going to process them. So example. So we're going to log phishing attempts in the smart contract using a nonce. Now a nonce is a number used once. So it's sequential, 1, 2, 3, 4, 5, 6, and it can only be used once. So Grug goes fishing 3 times. We had 3 different nonces with his user address. So we have an array. We had the nonce, we had the user address. And then Lady Grug goes to, and yes, that's spelled right. It's Lady Grug. Goes fishing 2 times, does the same transaction, but ends up with 4 and 5. So nonce 4 and 5. So we've got 5 phishing attempts. Now, when we're handling the phishing attempts on the process on the back end, we have our processor right here. It checks the contract and says, hey, are there any pending nonces? No? Well, then go back to sleep for a few seconds, and then it's going to try again. But if it's yes, it submits a transaction. What was the last nonce that was processed? And then you catch fish for all of the unprocessed nonces. This is key, because what this does is not only does it pick up any that were missed for whatever reason, but it also will process multiple nonces, multiple phishing attempts in a single transaction. Now that's huge because that's a gas saving, because we're paying for gas on the back end whenever we're submitting these transactions. So we can actually be more cost effective and more efficient. It's better for us in the long run. Then we store the last nonce processed, which is what's used here. So we know where to start again in the list. And then we go back to sleep. And then the whole process repeats itself. So by doing this, we've developed a system that doesn't rely on events, doesn't rely on hopefully catching them, and doesn't rely on a third-party service. This actually checks, so everything is actually written down, and then we read it. And by doing that, we actually have a much more secure and safe and solid system that'll handle latencies, or even if we have RPC issues on the event on the back end, as soon as it starts back up, it'll pick back up where it left off and continue on. So let's take a look at the code now. Okay, first let's talk about the phishing contract. So this is a Solidity contract for phishing. This is our phishing functionality. And if you look down here, we actually have our go fish function. And this is what happens. This is the function that gets called when a user clicks on go fish. And it submits all this information. And most of this we don't need to worry about in this discussion, and maybe sometime in the future we'll go over it. So essentially what this does is this takes the funds, makes sure and transfers the funds from the user, updates a couple things. It does this user last fish caught equals 99. The purpose there is so that now the UI knows that if it's 999, then the user is waiting on a fish. And so we set this to 999, and then when the GIF comes up, so that it's actually playing this script of Grug fishing, when we actually catch a fish for the user, we set this to whatever the idea is of the fish they caught. And so now the front end is like, checks this every once in a while. What's the usual last fish caught? If it's still 99, keep showing the animation. And so this is how we actually check to see when to stop showing the animation and start showing the fish that they caught, the results. So this transfer tokens, does some unwrapping and staking, which is another entire process, which we could go over at a later time. But the one thing we want to look at here is this go fish event. So this emits an event that is actually the user, whether the fishing pole ID, and bait ID, which we do not we haven't implemented the fishing pole and bait ID, but the code is in here, and so eventually we'll get there. But the thing to look at is the go fish event. And then the other function that we want is this catch fish event. And we have two, one catch fish by proxy and catch fish. And so I believe we're calling catch fish by proxy, which is, this is called by a proxy address, which I think we also have this here. There it is, and actually catch fish. Catch fish is the new one. So catch fish by proxy is the one that we're using for the event listener. And so what we're doing here is we're getting a random fish. We're wrapping it because we're using drift technology to wrap tokens, the winning tokens, into an NFT. And then we update the user last caught fish. So now the front end can be like, oh, so we did catch a fish, and then show the actual fish they caught. So this is how it works. Now with the new system, which we aren't going to go over yet. So let's talk about, let's go over and look at the event handler for handling this event and how it's actually being used. All right, so this is, let's look at our fishing processor. So the fishing processor, I have it checking every 2500 milliseconds, which is 2.5 seconds. It's going to call check pending knots. And so this is going to contact, so the way this works is basically it'll say, am I checking a pending? Am I currently checking? If I am, return, don't do anything. If I'm not, then it'll set it to true. And then it goes to is processing. But the idea is what it does is it does pending nonce to process, which is, if you remember from the contract, that was nonces that were pending. And if it's greater than 0, and then we say is processing true, we go to catch fish, then we set it to false. And what this is this kind of a fail safe so you don't get iteration, so you don't have it overwriting itself. So it can only be in this entire apparatus once, in this entire function once. And so it does catch fish, which is where it actually goes through the same process of catching a fish. And so it will catch all the fish that are pending. And so this system, and I think we didn't talk about this, pending nonce to process. Let's go over here and let's see, let's find this pending nonce to process. There we go. And we're going to say the go fish nonce, which is the current nonce for the next person that is actually going to go fish, minus the last go fish nonce processed. So in other words, this will give me if I have any nonces to process. So any fishing attempts to process, this will actually give me the number. And so if it's 0, we don't do anything. If it's greater than 0, then we call catch fish. And so this is a much more stable process that will handle anything, RPC going down or communication issues or things stop and we have to start them back up. This will actually handle any of those fishing attempts and pick all of those up. So we no longer have to rely on event, which is, like I said, generally works well, but almost always you will have missed events for whatever reason. And so if you have problems like that and you're relying on events, you need to find another way around that for stability. Otherwise, you're constantly going to have to be babysitting it, and you're going to have to users like, I fished and I didn't get my fish, and now you have to go get their address and go send them a fish, and it's a whole thing. Well, it makes much more sense to build for stability and strength so that you actually can set and forget. And so you shouldn't have any problems, whether the server restarts or the back end crashes, the RPC issues, whatever. As soon as everything gets going again, it actually catches all the fish and catches up from where it's at everything's written on chain, and so we don't have a problem with that anymore. So this is just a good coding practice. Good coding practice to bypass potential failures in your system. And so the first time I wrote this, I did it with the event handler, but I quickly learned that, flakiness on this is going to cause me problem, going to cause the user grief, poor user experience. So I would suggest, whenever possible, if you can code around events instead of relying on events. I mean, if you're relying on events for a timely thing, that's a problem. If you're relying on events for things like just cataloging NFT transfers and other things like that, the beauty part there is you can run it for a while and then even have a backup process that, that runs once every day that double checks all of the NFT ownerships. Maybe it's not as important. And when you're doing something that's a timely manner, like phishing, where the user's actually waiting, relying on events is probably not a good choice. And so you can see how we wrote around it and actually made a much more stable system. In future video, I'll probably talk about how we hosted this and some of the challenges there and the different services that we used. But I think that concludes it for now. I appreciate you watching. And until next time, keep building awesome tech.
And I don't really care what you think of me respectfully. You can kick rocks if you think you're fucking better. See, I will outwork you, turn you to an enemy. Hurt you so bad that you're gonna need some therapy. I got the motherfucking recipe. I've been cooking up hits, I'ma leave a legacy. You'll be looking small when you're standing right next to me. I'm 5'10", bitch, but I'm 10 feet next to me. I don't give a fuck what you say. Yeah, I'ma do shit my way. So you can go kick rocks, I'ma stack bricks up, build what I want to make. Cause I don't give a fuck what you say. Yeah, I'ma do shit my way. So you can go kick rocks, I'ma stack bricks up, build what I want.